Farmer Ed has 550 meters of fencing, and he wants to enclose a rectangular plot that borders on a river. If Farmer Ed does not fence in the side along the river, find the length and width of the plot that will maximize the area. What is the largest area that can be enclosed? So let's start by drawing our picture. We have a rectangular plot that is alongside of a river, and we're not going to put up fencing along the river. We have 550 meters of fencing, and so the fencing is going to go up along these three sides here. So we want to place that fencing in a way that it creates the maximum area inside. So we want to have the max area inside. Now with a rectangular plot like this, it has two dimensions. It has the length and the width. So we have the length and the width here. Because we're only using three sides, we're going to have two of the widths and only one of the lengths. And I can use that 550 meters of fencing, and if I take away the two widths, I have a formula to come up with the length. Now remember, our goal is to find the maximum area. So if we write out the formula for area of a rectangle, that's going to be length times width. But I'm going to get rid of the length by writing in that formula that I have, 550 minus 2w times w. If I distribute that w, I have the formula 550w minus 2w squared. And you can see that this is a quadratic equation. Negative 2w squared plus 550w. So since we're trying to find the maximum area, and this is a quadratic, I know that the maximum area is going to occur at the vertex. So I'm going to use the vertex formula, negative b over 2a, and a is negative 2 and b is 550. That's negative 550 over 2 times negative 2. So 550 times negative 550 divided by negative 4. Let's see, that works out to be sorry, I'm having trouble doing math in my head. Works out to be 13.75. And I can substitute this into the area function to find out what that maximum area is. So that's going to be negative 2 times 13.75 squared plus 550 times 13.75. So let's get our calculator for that. We've got negative 2 times 13.75 squared plus 550 times 13.75. So we have a mistake in how I calculate it. Let me do that over again. I have this extra parenthesis here. So negative 2 times 13.75 squared plus 550 times 13.75. So our maximum area would be 7,184 and 375 thousandths. So 7,184,375. So this number right here represents the width because the width is the variable that's used in our equation, and this one represents the area. So we're going to have a max area of 7,184.375 meters squared when we set a width of 13.75 meters. Let's read the directions one more time. Find the length and the width. I found the width, but I haven't found the length. So let's find the length. So, and a length of, I'll do 550 minus 2 times the width. That's 13.75. So I'll bring my calculator back and do 550 minus 2 times 13.75. So 522.5 meters. So we have a maximum area of 7,184.375 with the width being 13.75 and the length being 522.5 meters. Thank you for checking out my videos. Have a great day.